Okay, I think everybody has joined. So yeah, that whiteboard is now not available. So I hope everybody has understood what I have tried to show you on that whiteboard. Okay, I was trying to explain you the relationship between the variable, okay, dependent variable and the independent variable. How the dependent variable, in this case, the absorbance, dependent upon the concentration, that is the independent variable. Okay, we have seen the positive correlation. Okay, that is the direct relationship. As the concentration increases, the absorbance also increases. Okay, then I have told you about what is a blank, what are the standards, okay, how we use them for calibration. Okay, every instrument needs calibration for every analysis. Okay, if I'm doing some analysis today, I have to calibrate the instrument. If I'm doing the same analysis tomorrow, okay, again I need to calibrate that instrument tomorrow also. Every time, if I'm doing it in the morning or in the evening, both the times I have to calibrate the instrument. Okay, because the instrument doesn't know what is the concentration. It only knows how to find out the absorbance. The detector is going to sense the absorbance, and from the absorbance reading, the instrument must be told that this is the concentration, and then for the unknown sample, the instrument is going to automatically give you the calculation for the concentration of the sample. Is that clear? Then I have told you that if the absorbance to concentration relationship, if that relation is very good, then when there is a small change in the concentration, there is also a change in the absorbance. The absorbance changes much more when the concentration changes. And if the instrument has a low sensitivity, then even if the change in the concentration is more, there may be a less change in the absorbance. So we call that test or that device as a relatively low sensitive instrument. Okay. Then I told you about the specificity. Okay, what is specificity? The ability to correctly identify a particular molecule as the analyte molecule. That is the ability of some tests or some instruments. Okay, so in analytical terminology, okay, in analytical chemistry or analytical microbiology, these two terms are very important. One is the sensitivity and the other is the specificity. Okay, sensitivity and specificity, very important. Okay, then we yeah, I was telling you about the single beam instruments and the double beam instruments. So in the single beam instruments, what we have is there is a single slot which is available where we can put the vial. Okay, now this vial could have the blank, okay, that is the reference cell, and the same slot will also have the sample cell. Okay, that is to say, what we do is we put the blank first. Okay, then we tell the instrument that call this as blank, call this as 0, there is no absorbance. Okay, because no analyte is put in this particular cuvette. Okay, then we take out that cuvette, we throw away that blank. Okay, and then we put the then we put the standard solution, first standard or second standard in a series, of course. Okay, then when we put the standard, we tell the instrument, okay, call this as 10 milligram per liter or 15 milligram per liter, whatever is the standard, because it is a known quantity that we are adding. Okay, and then in that after the calibration is over, in that same slot we are going to put the sample cuvette also. Okay, so every time we have a next sample, we have to remove the first sample, put the next sample. Okay, the reference is also the same, so we put the blank tube in the same slot. That is called as the single beam instrument. Okay, the other types of instruments are called as the double beam instrument, where you have the blank put in the particular slot, and there is another slot in which we put the sample or the standards, whatever. Okay, so there are two different slots. One carries the blank and the other carries your sample. Okay, so what is the change in that instrument? Okay, the change here is that whatever beam of incident light is going to fall on the sample, that same beam is actually split up into two components. Okay, the beam which is going to be incident on the sample is split up into two parts. One part goes to the reference cell, that is the blank, and the other part goes through the sample cell simultaneously. Okay, so what happens is during the analysis of the sample, every time the detector is going to sense both simultaneously. What comes from the reference cell, that is the blank cell, and what comes from the sample cell. Okay, and a comparison is made simultaneously. Okay, the advantage here is that there is the errors are minimum here. Errors are minimum. Okay, because the instrument is going to sense the blank and the sample together at the same time. Earlier, what was the case? First, we are putting the blank and then we are putting the sample. So sometimes because of the time difference, because of the time lag, if there is some fluctuation in the reading, then that fluctuation is not taken into account. We never know whether whatever is the signal given by the sample, is it a real signal or whether there is an error. We don't come to understand that. Okay, but in a double beam instrument, because the same beam is split up into two components and simultaneously both the blank and the sample, they are measured simultaneously. Okay, so whatever is the reading of the blank, as I told you that every time the blank is not going to be zero. Okay, the instrument will call it as zero every time because it is simultaneously also checking the sample. Okay, so sample and reference, whatever is the reading of the reference, that is taken as zero. Okay, or whatever is the reading of that reference, that is subtracted from your sample. Okay, as if it is zero, and therefore you will get a very accurate reading of your sample. Is that clear to everybody? Of course, double beam instruments are more costly because they require two monochromators. Okay, monochromator for the reference and monochromator for the sample, right? Oh, sorry. Something that was not correct actually. The monochromator, of course, is the same, but the beam which comes from the monochromator, that is split into two components. Okay, so just make that correction, right? So now we come to the uses of the UV visible spectrophotometer, and I think everybody knows about it. What we can measure using the spectrophotometer. It could be a biomolecule like DNA or protein or whatever. So we measure the absorbance. Okay, essentially what we do is we measure the absorbance. Then we can also carry out certain experiments like the determination of the rate of chemical reaction. Okay, for example, if it is an enzyme substrate reaction. Okay, so what you can do is you add the enzyme, and after every 1 minute you can take the analysis. Okay, you can take the reading after every 1 minute. And therefore, at the end of say 5 minutes or 10 minutes, whatever is the change in that particular substrate concentration, okay, that you can measure. Okay, and therefore you can measure the enzyme activity per second or per minute. Is that clear to you? And that is how you can measure, you can actually study the enzyme kinetics or kinetics of any chemical reaction, chemical or biochemical reaction. Is that clear to you? With respect to time, you can carry out the analysis, right? That is called as rate determination or kinetics. Is that clear? The only thing which is important and that should be always borne in mind is that the sample must be a clear sample. It should not have any particulate material. It should not have any insoluble matter, okay, like dust, particles, okay, because if the sample is turbid, then the analysis will not be very, you can say, it will not be very accurate. There will be errors in the analysis. Okay. So this is one problem for you. There is a solution of nucleotide base, uracil. We are using a 1 centimeter standard cuvette. Okay, and this solution is going to show you an absorbance of 0.65 at 260 nanometer. Okay.
सर स्लाइड दिसत नाही.
Slide दिसत नाही. Okay. Let me share it again. Okay. दिसतंय का?
Yes, sir.
Okay. So we have a sample of nucleotide that is uracil, and this particular sample is showing you an absorbance of 0.65. Okay, that is OD units. And if it is a blank, the blank solvent, that is solvent which doesn't contain that nucleotide, that solvent is showing you an absorbance of 0.07. Okay, या दोन गोष्टी तुम्हाला दिलेल्या आहेत. And then assuming that the epsilon, that is the absorption coefficient of uracil is 8.2 into 10 raised to 3 per mole per centimeter, the question is to calculate the concentration of uracil. Okay, uracil concentration काढायचं आहे. And we have already seen this formula. Absorbance is equal to epsilon into length of the path, that is 1 centimeter, multiplied by the concentration. Okay, and therefore this particular absorbance which is given to us, okay, that is 0.65 for the sample and 0.07 for the blank. So if I subtract the blank reading from the sample, then I get the absorbance of 0.58. Okay, so this capital A actually is equal to 0.58. Is that clear? And now I want to calculate the concentration. So concentration I take on the left hand side. Okay, so concentration becomes equal to absorbance divided by epsilon multiplied by the length. So length is 1. So no problem. Okay, so absorbance is 0.58 divided by the epsilon value, that is the molar extinction coefficient, that is 8.2 into 10 raised to 3. Okay, and then if I calculate this, then I get this particular reading. The concentration is 7.1 into 10 raised to minus 5 mole. Okay, that is in mole. Right? कळतंय का सगळ्यांना? Very simple problem I have put here. That is for your understanding sake. I do not know if the examination will have problem-oriented questions. It may or it may not have. So it's better for you to go through these such problems which I am giving you in the lectures. Is that okay? Okay. Then in the next lecture we are going to see about fluorescence spectroscopy. Okay, fluorescence spectroscopy, and preferably I'll also try to cover turbidimetry and nephelometry in the same lecture. Is that okay? Do you have any questions? Any questions? Yes or no? Pathak, Vaishnavi, Vaidehi, any question? सगळ्यांना कळलं का आज काय झालं लेक्चर मध्ये ते?
Yes, sir.
Okay. Okay, so shall I close the meeting now? तुमची class test मला घ्यायची आहे. So what will be a suitable day for you for the first unit? Online test, multiple choice type questions. Multiple choice पाहिजे की descriptive पाहिजे तुम्हाला?
Multiple choice.
Multiple choice. Why? Why, Arshad?
Sir, exam type will be multiple, no?
Most probably. If it is online exam, most probably it will be multiple choice. Okay. अजून कोणाचा काही suggestion आहे का? You can all tell me, even on the WhatsApp group also you can tell me what type of exam you want. Accordingly, I'll try to set the question paper. Okay. When should I take that exam? Next week? मंडे ट्यूसडे असं काहीतरी चालेल का तुम्हाला? मे बी नेक्स्ट ट्यूसडे, इज दॅट ओके?
Yes, sir.
मग सगळ्यांनी अभ्यास करा व्यवस्थित. आय हॅव ऑलरेडी गिवन यू द बुक्स ऑल्सो. ओके, ई बुक्स आय हॅव सर्क्युलेटेड. आणि त्याच्यात काही असेल तुम्हाला अडचण वगैरे काही क्वेश्चन असतील तर तुम्ही डिस्कस करा माझ्याशी. यू कॅन ऑल्सो डिस्कस ड्युरिंग द लेक्चर्स. ओके, सो दॅट एव्हरीबडी विल अंडरस्टँड what is the difficulty and what is the solution for it. Okay, so bye everybody.
Bye,
Good
sir.
day. Yeah, good day.
Thank you.
Bye.
Thank you, sir.